This example comes out of section 7.2, transformations of exponential functions. So in this example, we're asked to transform the graph of y equals 4 to the x to sketch this new transform graph, which is y equals 4 to the negative 2 times x plus 5 minus 3. Two things you'd want to do right away before even really getting into the question. One, you'd want to have at least a picture of y equals 4 to the x to work from, since it says to do that even in the question. Transform the graph of y equals 4 to the x. Looks like this, regular exponential growth function, and it goes through, the 0.14, the 0.01, has an asymptote at y equals 0. Now, even without drawing anything, you might want to describe some transformations here. The negative sign up there is going to be a reflection, so reflect in the y-axis. If you wanted to, you could draw that, but we may also want to do the horizontal stretch by a factor of a half at the same time. So if I do those two things and sketch them, the asymptote doesn't change, y equals 0. The 0.01 doesn't change. But if I multiply this other coordinate, the x-coordinate, by negative a half, I'm going to have negative a half comma 4. So negative 1/2 comma 4 would be a decent point to label here. And I have a graph that now has different orientation, different shape than the original. Now the x plus 5 is going to be a horizontal translation, left 5 units, and the minus 3 is going to be a vertical translation, down 3 units. Again, you may choose to do both of these at the same time. Since this is going to result in my final graph, I'll draw it a little bit bigger. My asymptote is going to change, so I should be a little bit careful about that, because moving it left doesn't, but moving it down 3 does. So if I go down 3 units, 1, 2, 3, I have a new asymptote at y equals negative 3. Now I just have to take these 2 points that I've labeled and move them left 5 and down 3, and I should have new points. So from 0, 1, if I go left 5, I'm going to be at negative 5, and down 3 is going to be at negative 2. So 1, 2, 3, 4, 5 to the left, and down here, and I have negative 5, negative 2 as a point on my graph. The other point, if I go to the left 5 units, is going to become negative 5.5, and if I go down 3, it ends up being positive 1. So I end up with negative 5.5, positive 1, and I can connect my dots and have a curve looking roughly like that. That is the curve of y equals 4 to the negative 2, x plus 5 minus 3. With all 4, 1, 2, 3, 4 transformations described, and you could get full marks for a solution like that.